Alright, right on. In this video you are going to review linear equations. You're going to look at the slope-intercept, point slope, and the standard form of a line. And this is something that you learned back in Algebra 1, but if it's been a while for you, then this will be a great way for you to remember all the things you've learned because you're so stinking smart. Alright, remember that when you're looking at a line, the slope of a line, which is sometimes written as how much it rises over how much it runs, rise over run. You can find the slope by finding the difference in the y-coordinates divided by the difference in the x-coordinates, also sometimes written as delta y, change in y over change in x. So this formula helps you to figure out the slope of a line given two coordinates of 2 points. You can use that slope to write an equation of a line. The first form that you probably learned was the slope-intercept form, and just as the name implies, slope-intercept, it uses the slope of a line and the y-intercept. And we'll look at that in a second. The second form of a line that you maybe learned was the point-slope form. And again, just like the name implies, it uses the coordinates of a point, the x-coordinate and the y-coordinate, and the slope. And finally, the last form that we're going to look at is the standard form. It does not use the points or the slope, but it does allow you to quickly graph an equation using the x and y intercept. So, if you look at this graph, you can see a line graphed, and you can find the slope. Now, you can do that by using this formula that we talked about and figuring out the coordinates of these 2 points. Or you can also just count the rise over the run. So the slope of this line, if I pick this point and this point, I can count and go down 3, that's the rise, and over 1, 2, 3, 4, 5, 6, that's the run. So the slope of this line is -3 over 6, or -1/2. Alright, you can write an equation for this line. Once you know the slope, you can find where it crosses the y-axis or the y-intercept, which is right here. So for this line, the y-intercept is 3, the slope is -1/2, so the equation would be y equals m, -1/2, x plus b, which is 3. That's the slope-intercept form of that line. You can write the same equation, or you can write an equation for the same line in a different form called the point-slope form by using the slope and taking one of the coordinates of one of the points. So if I were to take this point right here, that point is the coordinate 2, 2. That means the x-coordinate's 2, the y-coordinate's 2. I can write an equation by writing y minus the y-coordinate, which in this case is 2, equals the slope, -1/2, times x minus the x-coordinate, which is also 2. That's an equation written in point-slope form. This is an equation written in slope-intercept form. Now, writing the standard form, we're going to look at that later, but let's move on. Some properties of lines that you need to remember include parallel lines and perpendicular lines. Remember that 2 parallel lines never intersect, but algebraically that means they have the same slope. They have the different y-intercepts, but their slopes are the same. Perpendicular lines, on the other hand, do intersect, and they intersect to form a right angle. So if one of them is a right angle, then all of them are right angles. Their slopes are opposite and reciprocals. So if one of the lines has a slope of 2/3, then the slope of a line perpendicular to that, that's the perpendicular symbol, would be the opposite. Opposite of positive is negative, and the reciprocal. The reciprocal of 2/3 is 3/2. Now this statement right here saying that their slopes multiplied together equal -1 just means if I were to multiply 2/3 times -3/2, I'd get -1. Now, unlike parallel lines, perpendicular lines can cross the y-axis at the same point. It's just required that they have opposite reciprocal slopes. So, if you look at these two lines, or two sets of lines, one is perpendicular, one is parallel, really quickly, this red line has a slope that's equal to up 2 over 1, 2 over 1. This blue line has a slope, and I can just pick 2 points and count down 1 over 2, down 1 over 2. So because these two slopes are opposite and reciprocal, you could say that these two lines are perpendicular. Same is true with the green lines. You can check their slope, pick a couple of points, up 1, 2, 3 over 1, so the first line has a slope of 3 over 1. The second line, pick 2 points, up 1, 2, 3 over 1. They both have the same slope, therefore they're parallel. Now notice they cross the y-axis at different points, but their slopes are the same, so they're parallel. Now let's do an example just to make sure you remember how to figure out all that you need to figure out to write an equation for a line. So if I give you 2 points, 1, 12, and 3, 8, these are coordinates of 2 different points, and I ask you to write an equation for a line that goes through these 2 points. There are several ways to do this. Here's one. First thing you can do is try to figure out the slope of the line using the formula that I gave you earlier, y2 minus y1 over x2 minus x1. Now it's really helpful if you label the points xy and xy, and more specifically this is point 1, this is point 2. And now all you have to do is replace y2 and y1, x2 and x1, and find the answer. So y2 is 8 minus y1 is 12 over x2 is 3 minus x1 is 1. So the slope that passes through these 2 points is 8 minus 12, or -4, over 3 minus 1, which is 2. That's -2. Now, this problem just says write an equation. So if I want to write an equation, I can write it in any form that I want to. Since I know the slope is -2, and I have 2 points to pick, I could use the point slope form. And to use the point slope form, all I have to know is the slope, which I do, and the coordinates of one point, which I do. Then I can pick either one. So I'm just going to write y minus, I'm going to pick this point because it looks easier, minus 12 equals the slope times x minus 1. That is an equation for the line. Now if this problem had said write it in slope-intercept form, then I could do the same thing and I could write it the way I have written it here, but now I can just take it a step further and make this look like y equals mx plus b. And you do that by distributing and solving the equation for y. So I get -2x, -2 times x is -2x, -2 times -1 is +2. The last step then would be to add 12 to both sides, and I get -2x plus 14. Two different equations for the same line. Both are correct. Alright, now, if I give you 3 different forms of an equation for a line, I need to know that you know how to graph each of those. So the first form that I'm showing you up here is in standard form. The benefit of standard form is that you can quickly find the x and y intercept and then graph the line. So I'm not sure what you've been taught, but this is the way I teach it. You can find the x and y intercepts quickly by covering up each term separately. So for example, if I cover up the y, now my equation says x equals 6. X equals 6 is the x-intercept. And that shouldn't have happened. x-intercept. And now if I cover up the x, it says 2y equals 6. Well, I can solve 2y equals 6 hopefully in my head. 2y equals 6 gives me y equals 3. That's the y-intercept. And now if I want to graph that equation, I make a graph. I find the x-intercept, 1, 2, 3, 4, 5, 6. That's where the line crosses the x-axis. I find the y-intercept, 1, 2, 3, up the y-axis. And that's my equation, that's my line for the equation x plus 2y equals 6. Alright, the next form given is the slope-intercept form, and it's exactly what it says. It's the slope and the y-intercept. The slope in this equation is 1/2. Remember, that's the rise over the run. We'll get to that in a second. The y-intercept is -3. So if I want to graph that equation, then I will start at the y-intercept. That means I'll go down the y-axis to -3, right there, and then I'll move according to the slope. That means I go up 1, over 2, up 1, over 2, up 1, over 2. And that's the graph of the line y equals 1/2 x minus 3. The last form is the point-slope form. That means it gives you a point and a slope. So I can look at this equation and know that my slope is -2. The coordinates of the point that it passes through are given after the x and after the y. Now the trick is that the formula is y minus the y coordinate. So, and x minus the x coordinate. So I always just say take whatever numbers are given to you and take the opposite. So the opposite of -3 is 3. The opposite of -2 is 2. So this line passes through the point 3, 2 with a slope of -2. And again, I can graph that. I make a graph. I go to the point 3, 2. 1, 2, 3, 1, 2. There's the point 3, 2. The slope of -2 means -2 over 1. So I go down 2, forward 1, down 2, forward 1. Or I could also go up 2, back 1, and so on. That's the line that passes through, or that's the line for the equation y minus 2 equals -2 times quantity x minus 3. Okay. To write an equation of a line that passes through a given point that's parallel, you just have to remember what we talked about earlier, and that is that parallel lines have equal slopes. So for this problem, I want to write a line that's parallel to this line. If it's parallel to this line, then I know what the slope is just by looking at it. It's right there. It's -5. If I have a slope and I have a point, I can write an equation. Y minus the y coordinate equals -5 times x minus the x coordinate. That's it. This is an equation for a line parallel to this line passing through this point. The second one says write an equation of a line that passes through the given point that's perpendicular. So this is the equation I want to be perpendicular to. This equation has a slope of 3/7. So if I want a line that's perpendicular to that, then I take the slope, I take the opposite of positive is negative, and the reciprocal. Flip it over. That's the slope of my new line. It's going to pass through this point, so I just write y minus the y coordinate equals the new slope times x minus the x coordinate. And subtracting a negative makes it positive. That is all.